Alrighty. All right, so today, let's get right into it. Today we're going to be getting into area between the curves with respect to y. The other video we were looking at x. This one we're going to be looking in regards to y and how that would work differently. So, say we were given these two functions. We meet at these 2 points, g of y, f of y. They could also be any f of x, g of x function being flopped around. Okay? How we were learning to take the area between the curves in the first lesson, we were taught that we're going to be cutting these infinitely small up and down. Well, we can see if we're doing that, we're just cutting into ourselves for some of this portion. It's possible, but sometimes we can just do sideway cuts and always be to the right of or always be to the left of each function. At other times, it's also hard to identify when we would need to use said objects, functions, or even which method to use. So seeing when we can always see that this function here is always to the right of or to the left of the other function in both cases. So they give us this formula. Because we have some experience with this, we could probably get right into it. So these are in terms of y. That'll be our big difference. G of y, f of y, dy. Everything's in terms of y. And the way we're going to approach this or tack this is we're going to take that right function and subtract the left function. So we're going to take right minus left, which is a little bit opposite of reading. So it's a different setup. Once we do a few of these, you should be off and running. The other piece or other big idea here is that these two bounds, because we were in respects of y now, and we were in respects of x, is these are going to be y values. So keep that in mind when selecting our bounds. These bounds are going to be y values. So I'm going to slow down for a second because I know I threw a lot of information at you, but that's kind of our big idea. Noticing that these are y values, or in terms of y, I should say, for all these blue little ideas. It's a little bit different notation. So take a second, read over this really quick. If you need to pause our video, but I'm going to head right into this first problem. So let's jump right in. Okay. They give me two functions, f of y and g of y. G of y being the red line in the graph and f of y being the blue line in the graph. There's two ways we can find out where our bounds are going to be. One being we can calculate it, which I did actually in the class, but for the guys watching the videos here, let's take a deeper dive. Well, I know they intersect here and here. I know my bounds are y values, so why don't I just see when the y value of that point and that point for my bounds? It's a pretty easy idea. Let's do it. So in this point here, if I go to the right, I can see that my y value is actually going to be right next door, -2. So I'm going to have my bound here of -2. And I'm going to call that my lower bound in this case because it's lower than the other point. Looking at this upper point and zooming in so we can see everything just fine, that is right on this line of y equals 4. So my top bound is going to be 4. Okay. Now that we have our bound set up, let's figure out which order our lines go. Here I have both lines, f of y equals y plus 1. I also wrote the x interpretive of that if you wanted to see that. And then I have g of y equals 1/2 y squared minus 3. If we are going to use the x interpretive of that function, we have to have this plus and minus symbol. And the reason why is we just have the positive our positive counterpart. We're only going to have the top portion, while the negative gives us this bottom portion. So different little idea there. So looking to our function there, or looking at the graph, I don't know why I'm yawning so much, but I'm yawning today. So we're going to take the function to the right, which is our blue function. We're going to put that one first. So f of y, that function is y plus 1. I'm going to subtract the second function, or the function to the left of that, which is 1/2 y squared minus 3, as you can see there. Oops. There we go. And at the end there, it is going to be dy, because we're working in terms of y. Sorry to be so dramatic, but it makes it easier. I'm going to rewrite this quick just to make it simpler. So we have the antiderivative of 4 on the bounds of -2 to 4. Y plus 1 minus, which should be my negative there, so minus 1/2 squared. Negative is going to go to the -3 as well, so it's going to be plus 3 dy. Going to do it one last time, oops, to make things look really pretty. I'm going to put my highest power first, so -1/2 y squared plus y plus 4 dy. Hopefully you guys can see how I got to there. So at this point here, we can't simplify anymore, so let's start taking the antiderivative. I'm going to kind of write over here. I'm also going to change colors here to notate that I'm taking the antiderivative. Let's go green. -1/2 is going to come out. We're going to take y and go up a power. And then we're going to take the reciprocal of that power and multiply by that. So -1/2 times 1/3 times y cubed. Let's move on to y. Y, we're going to go up in a power, so y squared, and then multiply by the reciprocal of the power, which is 1/2. Last piece is 4. 4 is going to be easy. We're going to do 4 and add a y to it, because it's a constant. Oops, and I forgot my negative sign for this one here. That would have caught me in class, but I got to catch myself. So we're going to plug in our bounds there, 4, -2, and let's do some subtraction. So let's plug in 4. I'm also going to simplify this front piece here. -1/2 times 1/3. It's going to be -1/6 times 4 cubed plus 1/2 4 squared plus 4 times 4. We're going to minus our second half here. So minus, that's still -1/6, -2 to the third, plus 1/2 y, not y, we're plugging in stuff, -2 squared plus 4 times -2. All right, let's simplify here. Simplifying the right side, we're going to get -1/6, 4 to the third, which is 4 times 4 is 16, times 4 again, I believe, is 64. I'm going to double check my math really fast, just because I want to give you guys exact answers. Four times 16. I'll even do it really quick, just to make sure. 40, 24, 64. Yep. I'm sorry. My brain's kind of waking up yet, so just probably like your guys' is too looking at me. 64 plus 1/2 times 4 squared, which is 16, plus 4 times 4 is 16. Okay, we're going to do some multi-step kind of simplifying here, so I might go a little quickly on this one. So it's still -1/6 times -2 to the third, 2 times 2 is 4, times 2 is 8. Because it's the third power and an odd power, it's going to be negative 8. Plus negative 2 squared is 4, divided by 2 is 2. And then the last one, we have 4 times negative 2, which is actually just negative 8. Awesome, awesome. Let's keep going here. 64, I believe, is not divisible by 16, and I should be correct with that. Or divided by 6, not 16. It's not, so I'm just going to leave it as an ugly fraction. So we have negative 64 over 6 plus 8 plus 16. And I'm going to distribute my negative while also doing things. So negative 8 can go on to, or divided by, or times negative 1/6 is going to give me 8 over 6. And we're going to take a negative because we're subtracting. So negative 8/6. I have just 2. I'm subtracting the 2, so it's minus 2. I have negative 8. Subtracting the negative, so it's going to be plus 8. Simplifying here. We just keep going, don't we? I'm going to leave it as negative 64 over 6. I guess we can let's combine these two real quick. So negative 64 minus 8, or 64 plus 8, is going to be 9 times 8, which is 72. It's negative 72/6 plus 8 plus 16 plus that 8 is 32. Minus 2 is going to be 30. If we can get some big thing over 6, so we can take 30 over 1, multiply that to 6 over 6. We'll get 180 over 6. Yeah. So 180 over 6 minus 72 over 6. It's going to give me 108 over 6 as my answer. Which that, I believe, does divide. 108 over 6, actually, is equal to 18. So, as you can see here, it's kind of those same steps as yesterday or the lesson before. Adding in some different ideas of using y, and just kind of the setup is different, but once we get cracking and going, it's that same process. So I'll zoom out here for a second if you need to pause and look at my work. I'll actually even move this over so you can see my whole screen. But if we're good there, we're going to keep going. So this is our example. In R, or let R be the region in the first quadrant bounded by the x-axis. So we're going to be bounded, I'm going to draw my line here, by the x-axis. And the graphs, y equals ln x, which is in green, and y equals 4 minus x, which is in red. Find the area of R in regards to y. In regards to y is what I put into this problem when looking up these problems for AP. The reason why is because they don't directly tell you. What my big hint was, or what my big thing I saw was bounded by the x-axis. So seeing this sentence kind of spooked me into thinking, okay, well, I'll have a bound here. Good. The other thing I noticed is if I asked you to find the area under the curve and you were trying to do it top down, do you really have a top curve? You don't. There's no top curve. This is my top. If I split it in half right here at this point, this would be my top curve, and y equals 0 would be my bottom one. And then on this side, it would be y equaling 4, like the red curve, over y equals 0 again. So it doesn't necessarily work for us there. But if I go from right to left, I'm always going from one curve to the other. That's why we have to do this in regards to y. I gave us a little hint here, gave us our intersection point there, this guy there, just to kind of help us out, keep things moving forward. So Let's start by starting to set this up. Well, I have to do something first. Actually, that and that are in terms of f of x, or in terms of x. We have to figure out our equations for f of y in both cases, or solve for x. Well, let's solve for x. How do we get rid of ln x? So we do that is we take the power to e on both sides. So I'd have x equals e to the y. And for the red function, I just gotta add, we'll subtract 4 and divide by -1. So if I subtract 4, I get y equal, or negative x equals y minus 4. Divide by -1, I'm going to get 4 minus y. These two are my two functions. Awesome. Well, let's set up our antiderivative. The antiderivative of our bounds, looking at y values. What is my bound when I have the x-axis as my bound? It's 0. Oops, now that covers that. I can't win. I'll have to zoom out here. 0. My top bound is at this intersection point, and it's my y value there. My y value there is 1.074. Awesome. Now we gotta set up our antiderivative. Which function is the right function versus the left function? The right function is the red function, f of y equals 4 minus y. And put that back on top for right now. So we are at 4 minus y minus our right function, which is e to the y dy. Can we simplify this at all? Answer to that is no, we can't. So we're going to jump right into the next step. Start taking the antiderivative. The antiderivative of 4 is going to be 4y. The antiderivative of negative y is going to be negative. We're going to go up in a power, y squared, and then multiply by the reciprocal, 1/2. For the last part here, we're going to do the antiderivative of e to the y, or negative e to the y. -1 stays there. The antiderivative of e to the y is just e to the y. We're going to get our bounds from 0 to 1.074. Going from there, I'm just bringing up my notes so I can give us exact values. And I actually even calculated this one just on the calculator. So I'm just going to write it out just to write out and be complete, because it is such a gross number. So I'm going to take 4 times 1.074 minus 1/2 times 1.074 squared minus e to the 1.074. I'm going to subtract the one at 0 here. So subtract 4 times 0, which is 0, minus 1/2 times 0 squared, which is 0, minus e to the 0, which is -1. So to solve this, or if you want to type it into your calculator, it's going to be 4 times this number here, minus 1/2 times 1.074 squared, minus e to the 1.074, minus a -1, so plus 1. The answer, when you type that all into your calculator, that you should get is 1.792. If my math is correct. So check your work with that, but that is what I got there. I'll move this to the side for right now so you can see the whole page. Awesome. That's our second example. Let's get into the third one. Third one is a multiple choice one. Real nice and easy. It's a practice problem. The curve x equals 1/4 y squared plus y plus 1. And x equals 2y plus 4 are graphed below. Which expression represents the area bounded by the curves? Okay, well, let's look at it here. We have multiple choice question, right? Let's start by eliminating some. Well, how are they different? I have 2 set with this bound, and I have 2 set with this bound. So quickly, let's find the bounds and get rid of 2 of our questions. Well, how can we find our bounds? We can look at the graph. It's crazy. Looking at the graph here, let me get rid of that line real quick. We can see that we intersect here, and we intersect there. The question is, what are our y values at these points? Because we're doing this in regards to y. So that's, if this is 0, we're got -1, -2. So my lower bound is -2. Look in here as well. This line is 5. We go up one more, it's going to be 6. So I know my bounds are 6 and -2. Well, there's only 2 with that, so the other 2 are not our answer. Now I have to figure out if it's going to be this or this. What am I taking the antiderivative of? Why I could do that is start by setting it up. So which function is my right function here? I'm also going to erase some just to make this a little easier to look at. My right function is this function here, the straight function. Do I have a linear line in my curves? And the answer is yes. My linear line is 2y plus 4. Next, I'm going to subtract the left function, which is my quadratic. It's 1/4 y, minus 1/4 y squared plus y plus 1 dy. That doesn't match up with anything yet, so let's just keep simplifying. My front's going to stay the same, 2y plus 4. I'm going to distribute my negative, so it's -1/4 y squared minus y minus 1 dy. Again, that doesn't match up with anything just yet, so let's simplify it one last time, hopefully. Simplifying here, let's combine like terms. I'm going to put my largest power out front, so -1/4 y squared. I have 2 things of y. I have 2y minus y, so I'll be left with it's just 1y plus y. Last part there, I have a +4 and a -1, so I'm going to have -3 dy. Well, what I notice of this is that this guy matches up with this guy. So my answer here is going to be B. Now, on your own, you should definitely try solving this problem as well, get some extra practice in. For sake of everything else, I can kind of give you the answer here. The answer should be 21 1/3. But check my work. Go through the problem, make sure I'm right, check your bounds, do all that fun stuff, and see where you actually get to. Alrighty. So in this one again, just a quick review, we went over finding the area between 2 curves with respect to y. So we noticed that sometimes we can't see, we're hitting ourselves in the function. So we might have to come at it with a different approach, so we're always hitting both functions. But, alrighty. I hope you have a great rest of your day, and thank you for watching.